Guys, so good morning, I hope you're well. Guys, today I'm just gonna start with the grade 12s, how to determine the inverse of a function. So we are going to start right there because inverse functions are done in the grade 12 year, and there are important things that obviously come with determining the inverse of a function. We need to be able to know how to write an equation that is a function, how to represent it as an inverse of that function. So I'm going to look at three types of function and how to represent them as the inverse. So first and foremost, we have the function which is in the form y is equal to mx plus c. This here, guys, is a linear function. Okay, it's a linear function, y is equal to mx plus c. Then 2, we are also going to look at how to determine the equation of a parabola function. So this is we call it a quadratic function. And then last but not least, the third type of function that we are going to look at how to determine its inverse is what we refer to as a exponential function. So guys, this would be what we typically know as an exponential function. So this is the type, is a exponential function. Okay, so it's very easy basically. An inverse function, you will see a linear function is the function that basically will have its x variable will have a exponent of 1, right? That's how we know that it is a linear function. A quadratic function, on the other hand, its x variable will have an exponent of 2. And then last but not least, the exponential function, it will have an exponent that is the variable x. So that's how you are able to see or distinguish between these types of functions. So what we are going to do now, okay, in maths we know that f of x is actually just another way of saying y. Okay, so f of x is what we refer to as functional notation. And I just want you guys to know that this functional notation is just the way that we represent the value y. Okay, so functional notation, f of x, all right, is just another way of us saying y. Okay, so if we want to say y, just a way of saying y is f of x. If you want to say f of x, another way of saying f of x is to say y. That's very important. So f of x is just the y variable. Okay, so let us look at how to linear function. How do we determine the equation of an inverse function? So if we are given a linear function, how do we convert that to a inverse? How do we convert that to an inverse function? Because it's very important to know how to do that. Okay, so we are going to first look at linear, how to convert a linear function to its inverse. Okay, so let's say we are given the function f of x is equal to 2x plus 1, and they say to us determine the inverse. Now this is notation that we use to signify inverse of a function. So basically f, and this f has an exponent -1. So instead of saying f of x, which is the original function, okay, the given function, so if we want to say how do we then convert this function f of x to its inverse, so this to the power -1 is just to signify that we are looking at we are looking to convert it to the inverse function. Okay. But what is the function that we are given? This is important. So we are given a linear function and we are asked to determine its inverse. Okay, so the way we go about this, guys, is very straightforward and simple. So step by step, this is what we do. So firstly, write down the function that we have been given, which is f of x is equal to 2x plus 1. Now, remember what I said about f of x. We can write f of x as what? As y. So we have y is equal to 2x plus 1. So that's the first step. We need to write this inverse function. We need to convert it from the functional notation to its y is equal to 2x plus 1. Then, step 2. Because we want to write this as the inverse, okay, for the inverse, what we do is we are going to first swap x and y. So what you see here is that for the function, firstly, okay, for f, obviously f is y is equal to 2x plus 1. Then for the inverse, we need to first swap x and y around. So what you see now is that instead of y being the subject, we have x. In the place of y, we've basically swapped it with x. In the place of x, we've swapped it with y. Okay, so that's the first step. We swap x and y. Then we follow that up with, we try and make y the subject of the formula. So if you think about it, x is on the left. We take 1, 2y plus 1, there are two terms. So what we do is we transpose the 1 over to the left hand side. So now we are left with x minus 1 is equal to 2y. Okay, why are we doing this? We want to make y the subject of the equation. So x minus 1 is equal to 2y. Then after that, because 2 and y have a relationship of multiply, to get rid of this 2, what do? We divide both sides by the coefficient, which is 2. Okay, so x minus 1 is equal to 2y. So practically speaking, you divide both sides by the coefficient of y, which is 2. Then you get x minus 1 over 2 is equal to, what's 2 divided by 2? That is y. Okay, so you can then conclude and say, therefore, y is equal to x minus 1 over 2. All right. And then obviously what's left then is to basically make this amazing conclusion that the inverse of this function, f of x is equal to 2x plus 1, is actually equal to x minus 1 over 2. Okay. Right. Some people may write this as f, the inverse of x being x over 2 minus 1 over 2. Remember that the denominator is the same, it's 2. So you could write this function. Some people would insist that obviously they want to see the mx plus the c. So obviously the coefficient of x is 1 over 2 minus half. So if you insist on actually splitting it, then obviously you can see that the inverse of this particular function is x over 2 minus half. But you can leave it in this state. It's no problem. So I just want to recap again, what did we do when we were expressing f of x? Because remember, f of x, we are supposed to determine the inverse function. So what we do, like I said, first and foremost, we write down the original function f of x, which is 2x plus 1. Then we obviously express from the functional notation f of x, we write y, and then 2x plus 1 follows, so that we can work with y and x. Then for the inverse, remember, the first step, we swap the x and the y. So y gets swapped with x gets swapped with y. And after that, we make y the subject of the equation. By saying we make y the subject of the equation, we strive to make this y to be isolated on one side. So x is equal to 2y plus 1. We transpose the 1. We get x minus 1 is equal to 2y. We are so close to isolating the y. Then what we do is, because 2 and y have a relationship of multiply, we divide both sides by 2. The inverse of, so we apply the inverse of multiplication, which is division. So we divide by 2 both sides. Then after that, we get x minus 1 over 2 is equal to y. Now y has been isolated. Because y now is isolated, we can then conclude and say, therefore, y, which is isolated, is equal to x minus 1 over 2. And then obviously we can then write the inverse of the function is equal to x minus 1 over 2. And that concludes it. So basically, guys, it's simple. Okay, how to represent a linear function, how to determine the linear functions, the inverse of that function. That's how we do it step by step. Okay. Let's move on now to a quadratic function. And let's see how do we go about representing a quadratic function, representing that as its inverse. So let's say we were asked to determine the equation of the inverse of f of x is equal to 4x squared. Now you might note that the way that this has been asked, it says determine the equation of the inverse of f of x is equal to 4x squared. So they've said it in what here? In words. They said determine the equation of the inverse. Whereas here in the previous question, they had said, look at this, determine the inverse. Do you see this f to the power negative 1? This signifies inverse in mathematical notation. All right, so they can say it in words or they can say it in mathematical notation. This also stands for inverse. And if you remember, like I said in the previous question, if we're given a linear function f of x is equal to 2x plus 1, we simply write down the function. Then because we want its inverse, we swap. Okay, remember the f of x is y. Sorry, before we swap, the f of x is y. And then obviously this is 2x plus 1. Then for the inverse, what we do is we say, we write in the place of, so we swap x and y. So in the place of y, we write x. In the place of x, we write y. Then after that, we try and make y to become the subject of the equation. We take the positive 1, we transpose it, we get x minus 1 is equal to 2y. Then we divide both sides by 2y because 2 is the coefficient of y, so we divide both sides by 2. Then y is now the subject because 2 divided by 2 is 1. It leaves us with y is equal to x minus 1 over 2. Then we can then conclude and say, therefore, y is isolated, so y is equal to x minus 1 over 2. So then we can write in functional notation of inverse, we say the inverse of the function is equal to x minus 1 over 2. And this basically would be our inverse of the function. So now let's look at the quadratic equation. It says determine the equation of the inverse of f of x is equal to 4x squared. So what we are doing here, we are just determining the equation, all right? There are no restrictions or anything like that. We are just trying to get the skill of being able to write a function as its inverse. We are going to look at other things later on, but for now we are just trying to cultivate and sharpen up the skill of writing a function as its inverse. So first step, we first write down the function. Obviously this is quadratic. Then obviously y and x is what we want to see. Okay, So y is equal to, remember from functional notation to, in terms of y and x, this is y is equal to 4x squared. Now for the inverse of the function, we know that y becomes x, x becomes y. So basically this is the part where we swap x and y. Okay, I'm just writing the notes on the side so that you guys can appreciate what I did. Then 2, you then try and make y the subject of the formula. But what is standing in the way that y be isolated? We have 4, which is a coefficient of y squared, that needs to go first. And then after that, we need to eliminate the squared. So how do we get rid of the 4? The relationship of 4 and y squared is one of multiply. So in order to get rid of something that's multiplied, we actually divide both sides by that particular thing. So first step is we divide both sides by 4. What happens? We get left with x over 4 is equal to what? Y squared. Are you with me? Now we are close because y squared, okay, is close. The y is close to be isolated. So the y squared, what do we do to get rid of the square? We use the inverse of square, which is the square root. So what we are going to do is we are going to take the square root on both sides. All right. But remember, when we take the square root on both sides, remember for this side we are wanting to eliminate the square. So what we do is we put plus and minus on the other side. Then that basically leaves us with what? Y is equal to the square root of plus minus the square root of x over 4, positive or negative. Then we can conclude, therefore, y is equal to plus minus x over 4. Okay, and then obviously because we want to formally write this in functional notation, because that is the formalized way, f, the inverse of the function, is actually plus minus x over 4. Okay, so that is just us being able to represent this. Okay, but here's something to note here. Okay, this inverse, if we were to actually okay, so basically something we are going to note here is that this inverse, it gives us two outputs, okay, for each what? For each input, okay, and this means that the inverse basically is not a what? Is not a function. So that is why for a parabola function or a quadratic function, we usually speak about restricting the domain of the function, because it's only when we restrict the domain of the original function that we are able to express the inverse of that function as actually being a function. Because a function, obviously, we are told that a function can either be 1 to 1. In other words, for every x value that we put in, we get one unique output value. Okay, so for every x, we get one unique y value, and vice versa. Okay, that's why we call a 1-to-1, we regard a 1-to-1 as being a function. So if it's 1-to-1, it is a function. Okay, 2, a many to 1 is also a function. A many to one. Okay, actually let's just say for every y, because 1 to 1 means for every y there is one unique x value. Okay, this is very important. Then a many to one. In other words, a many to one is also a function. It is a function. We regard it as a function because for every y, for every multiple y value, okay, for every x value, okay, so basically this is what I mean. Okay, so a parabola, if you have a quadratic function, right? I'm gonna just draw a random parabola here. Okay, so here's the thing, guys. A parabola is a function. So for instance, we can have a x value here, which is 4, a y value, which is -4. So what you are going to notice is that there are many x values. In other words, there are many x values. These many x values that you see here is you're seeing -4 and 4. That is many. But both of these x values, guys, they have a common y value. All right. And the y value, obviously, of the x-axis is 0. So you have different x values. That's why we say many. And then to 1, both of them have a single output value, which is 0, both of them. You know that the y value here, if you were to write the coordinates, obviously this is 4 and 0, and here this is -4 and 0. So that's why we call it many x values, but they have one y value. So this here is what we also call a what? A function. And it is not a 1-to-1. It is a many to one function. I hope that makes sense. So the thing is now, what's funny is that if we were to sketch the inverse of this function, we'll actually find that the inverse of the function is actually not a function because it exhibits this quality, and that is it is not a many to one, it is a one to many, which is a problem. So that's why they are saying here, for instance, this inverse, which is the square root of x over 4 plus minus, this is grade 12, plus minus, this inverse gives 2 output for each input. All right. In other words, this is a typical one to many. So they say this means the inverse is not a function. Guys, in order for a inverse to be regarded as a function, it has to be 1-to-1. In other words, for every single x value, there needs to be one single output value, meaning one y value. Okay, that's 1-to-1. We regard 1-to-1 as a function. Or 2, it can be a many-to-1. A many-to-1 is like this parabola, like I said, for many x values that you have, you will find that there is this one unique y value that these many x values will share. That's why we regard it as a many x values to one y value. All right. Okay. So we regard this parabola as a function, but then 1-to-many is not a function as per the definition of what a function is. We regard this 1-to-many as a relation. We can't properly regard it as a function. Okay, so more about this later on. But for now, what are we obsessed with? We are obsessed with determining the equation of the inverse of a function. So we've just done how to determine the inverse of a function for 2x plus 1, which is a linear function. And then we moved on to determining the inverse of a function, which is a quadratic function. So let's go and look now at the last type of function, whereby we want to be able to write the equation of the inverse. Okay? All right. One last example is for our exponential function. Okay, so let's look at how to determine the equation of an exponential function. So let's just write the question says determine the equation of the inverse. Now, we're going to look at a couple of examples. Let's look at f of x is equal to 3 to the power x. Then 2, we're going to look at f of x is equal to negative 5 to the power x. And then 3, we are going to look at, let's say, p of x is equal to 3 to the power negative x. Now guys, like I said to you initially, f of x just means y. F of x means y. P of x also means y. Remember, they can basically introduce any other letter, but all of these just are functional notation, but they all stand for y. Okay, so let's go and first write the inverse of the function for f of x is equal to 3 to the power x. So this is an exponential function. Okay, and an exponential function, guys, is definitely, as we see it, f of x is equal to 3 to the power x. So step number 1, how do we represent this as its inverse? First step, we obviously don't write it as in functional notation, but we write it in terms of y and x. That's step number 1. Then for the inverse, we are going to then say the following. We swap the x for the y. So x is equal to 3 to the power y. Are we together? X is equal to 3 to the power y. So we swap first. And then step number 2. Please guys, note the following. There are important things we need to note. There is what we refer to. If x is equal to a to the power y, then we are told that we can use the log to express this function so that y becomes the subject. So in other words, what are we saying? In order to find the inverse of an exponential, okay, in order to find the inverses of exponential and logarithmic functions, you need to know the following conversions. So these conversions, you need to know them, okay? So if x is equal to a to the power y, here is the thing. Then you can say y. So where does this y come from? It is the exponent, which then becomes the what? The subject of the equation. A here is what we refer to as a base, all right? And this base will then feature in the log as a base as well. Then x, which was the subject, features as x, all right, next to log. So the way we read this is they say y is equal to log x, the subject of what the exponential equation was, base a. This was referred to as a base even when it was in exponential form. The exponent becomes the subject of the log equation. Exponent becomes the subject, guys, of equation. So in actual fact, what we are saying is that the exponent becomes the subject all the time of the log equation. The base is the base of the log expression. The x is written as a variable next to log. Okay, so if we use this understanding, then this means x is equal to 3 to the power y becomes what? The subject becomes y, because we said the exponent becomes the subject. Log gets introduced. The base was 3, so that base still remains as the base of log. We write it as a subscript of log. Okay, when I say subscript, guys, it's like we write it not as an exponent, but we lower it from the log. That's what we refer to as a subscript. So this 3, which is the base, still becomes the base of log. Then x, which was the subject of the exponential equation, is simply written next to the log. So this here, guys, is the inverse of the function f of x is equal to 3 to the power x. So we can then conclude and say, therefore, the inverse of 3 to the power x is equal to log x base 3. This is grade 12. Okay, guys, I hope that is, very nice and smooth. So this is very important. If x is equal to a to the power y, then we can express this as y. Remember, the exponent becomes the subject of the log equation. A becomes the base of the log, as it was the base of the exponential equation. X, which was the subject, becomes the variable next to log. So we read this as y is equal to log x base a. Okay, and therefore this means that x is equal to 3 to the power y becomes y is equal to log x base 3. So therefore the inverse of the function can be expressed as log x base 3. Okay. Let's look at number 2. F of x is equal to negative 5 to the power x. So let's look at this. We want to also express this as a inverse of the function. So first and foremost, we have f of x is equal to negative 5 to the power x. We then write this in terms of y and x. Step number 1. Step number 2, for the inverse, because we want to actually express this as an inverse, we first do what? Swap x and y. Y becomes x, x becomes y. Alright, I hope that makes sense, and I hope you guys can see that with clarity. Okay, x becomes y, and y becomes x. Okay, so far we're going together. I hope we are. I hope everybody is good. Okay, hopefully so far we are going together. Now you can see, guys, that x is equal to negative 5 to the power y. Yeah. Because remember, every time we are writing or expressing the inverse, the first step we always do is we swap the x and y. Whether it's a linear equation, linear function, I just want to show you guys. Okay, f of x is equal to 2x plus 1. Alright, there's a fundamental step that we do for all of these functions. F of x is equal to 2x plus 1. What we write in terms of y and x, then what we do, we swap x and y. Okay, that's the first step. Then obviously for a linear equation, we make y the subject. Okay, for a quadratic function, same thing. Okay, f of x is equal to 4x squared, y is equal to 4x squared. We swap x and y. X becomes y, y becomes x. Now for an exponential function, we are saying the same thing. We write f of x is equal to 3 to the power x. We write it in terms of y and x. Then we swap x and y. Then we remember that the exponential function can be expressed as a inverse, being a log function. So that is why we go ahead and then we utilize what we've learned here about this particular way of expressing exponential into log form, which is very important. Okay, so this is very important. So again, f of x is equal to negative 5 to the power x. Step number 1, we write it in terms of y and x. There you see y in terms of is equal to negative 5 to the power x. So far so good. But now take note, guys. Here we have x is equal to negative 5 to the power y. Okay. Now what we are going to do, guys, is we are actually going to make it a point that we divide both sides by a negative. The reason why we are going to do that, guys, is because we do not want our base to be a negative. I mean, we don't want our base to become yeah. So what we are going to do, we are going to divide by negative both sides. So what we are going to do now is we're going to say x is equal to negative 5 to the power y. We divide both sides by negative 1. Okay, then we have negative x, because x divided by negative 1, positive divided by negative is negative x, which is equal to negative divided by negative. That leaves us with 5 to the power y. Hopefully, guys, you can see this and why it kind of makes sense, all right? Because what we don't want is for our base in the log form to be a negative value. So that's why we divide both sides by what? By negative, okay? Then, from here, we can then write this in log form. Remember, when we write it in log form, what happens? Y becomes the subject because the exponent becomes the subject. Then the base was 5, so we're going to say log still base, all right, 5. Then this x, it's negative, so we write it as negative x next to the log. Okay, so therefore that means our inverse function for the exponential equation 3 to the power y is equal to log base 5 negative x. And that's it. Done and dusted. Okay. So this is grade 12, guys. This is grade 11. This does not feature how to write an inverse. Inverse of a function is a concept that's covered in grade 12. So our grade 11s don't have to worry about this as of yet. This will be a pain of yours next year if you are grade 11 doing caps. Okay. So for now, it doesn't have to be a worry of yours. Okay. Then the last question that I had there was p of x is equal to 3 to the power negative x. I want to express that as an inverse function. So p of x is equal to 3 to the power negative x. 3 to the power negative x. So let's go, let's take this one step at a time and unpack it. So once again, let's see if people have been listening to me. Step number 1, guys, what do we do? Maybe someone can comment there in the comment section. What do we do? Step 1. I need to see if people were listening. Rewrite. Okay, very good. We rewrite. P of x obviously can be written as y is equal to 3 to the power negative x. Very good. That's step 1. Thank you, Ghana M1. Then 2, what do we do? After we've rewritten, okay, for the inverse of the function, thank you, Simelani Mila, we swap. X becomes, y becomes x. Okay, remember, y becomes x, and the x becomes y. Okay, still retain the negative sign. All right, all I'm doing here, guys, is I am x, y becomes x, x becomes y. Okay, and this is amazing, this is beautiful, it's fine. All right, so what's beautiful is that the coefficient of 3 is not negative, so I don't have to worry now about dividing both sides by a negative. Does that make sense? Because 3 here, okay, I don't have a negative value, because remember, I don't want a base that is negative. So that's why I usually insist that if this base here for this exponent has a negative in it, I would divide both sides by a negative. But we don't have that, so we are fine, we are good. So the next thing we are going to do now is we are going to express this exponential function in log form. Okay, so we want y the subject, so obviously the exponent negative y becomes the subject, followed by what? By log. And then this x becomes log x next to the log, and then the base was 3, so the base is still what? 3. But remember, guys, our subject needs to be positive. We can't have a what? A negative subject. So what we do then is what is the coefficient of y? It's -1. We divide both sides by a -1, which therefore means that our final logarithmic function is log x base 3. Okay, then we can conclude very nicely that P inverse, because remember this time we were given P of x, so we need to be consistent. We can't say F, we say P inverse. Okay, the inverse of the function is equal to -log x base 3. Okay, I hope, guys, you can see how easy and how nice these questions can be. Okay, now someone else might be like, but then, okay, if that's the case, we can say thank you very much, we love it, we love it, but then now what happens? How do we change a given log function to exponential? So let's look at that. How do we change log to exponential? Because we can change exponential, meaning we can change the exponential function and express it as its inverse, which is the log function. But how do we change the log function, if we're given a log function, back to exponential? So that's what we're going to look at very quickly. And for that purpose, I just want us to look at a quick thing here. And that is, if x is equal to log y base a, then if x is equal to log y base a, then y is equal to a to the power x. So I'm sure, guys, by now you can see, man, this thing is like, oh, okay, so basically there's nothing much in this thing, in all honesty. Okay, so I need to just grasp these rules. Okay, because I mean, this is basically, you remember what we said, y is equal to a to the power x, the exponent becomes the subject, the base becomes the base still, if we're converting from exponential to log. Okay, so the exponent becomes the subject, the base becomes the base of log, and then y would be simply stationed next to the log. Okay, yeah, I think as long as we know that, we should be fine. So this is an important thing that we need to know, okay, as a rule. So here's the thing. Let's look at a few questions, and then we can call it a morning, guys. Determine the equation of the inverse of, and let's look at f of x is equal to log x base 3. 2, let's look at these respectively. 2, let's look at let's say m of x is equal to log base 5 negative x. Okay, let's look at these two, and then we'll look at one last one at the end. Okay, so let's look at this, guys. F of x is equal to log x base 3. All right, so first step, obviously, in terms of y and x, let's start always there. In terms of y and x, f of x is y, okay, log x base 3. Then after that, okay, we obviously, guys, will swap. We still play the swapping game. Okay, for the inverse, x is equal to log y base 3. Y becomes x, x becomes y. So we still swap. Okay, and then we can then now express this in exponential form. Okay, so the way I like to basically say it to my learner is that I say the base goes and kicks the x. Okay, it's like 3 kicks the x. And then what happens is that when x gets kicked, he becomes an exponent. And then this y becomes a subject. So in other words, y is equal to 3 to the power x. And that is our inverse, guys. Simply put, we've basically utilized this rule. So the way I tend to make my learners remember is that the 3 kicks the x goes up, and then y is isolated. Log falls away and y becomes isolated. So therefore we can say the inverse of the function is equal to 3 to the power x. Okay. Yeah, I know, hey? I usually say that so that they don't forget. Okay, so log to be changed to an exponential function. 3 kicks x goes up, becomes an exponent, y gets isolated, log falls away. And that's basically the inverse. So the inverse of the function is equal to 3 to the power x. Okay? And what's nice is that now even you can express this inverse back in that form. You know, you follow obviously the steps that you know that we take when we change a exponential function back to a log function. Okay, let's look at this one as well. M of x is equal to log negative x base 5. So let's look at that. So first step, as always, y is equal to log step number 1. Okay. Step number 2. For m inverse, what do we know? X is equal so since this is in the bracket, negative x is equal to what's happening here? What am I doing? Sorry. X is equal to log negative y base 5. Okay. So I nearly butchered that one because we swap x for x and y, right? Y becomes x becomes y. So obviously I'm changing this x to y. It's still negative. I'm changing this y to x. It's still positive, okay? Then after that, what do we then do? What I said to you initially. 5 goes and kicks the x. So what do we have? Negative y is equal to 5 to the power x. Okay. Then obviously because y cannot be negative, I obviously divide both sides by a negative 1, which is the coefficient of y. That leaves me with y is equal to negative 5 to the power x. Therefore, the inverse of the function is negative 5 to the power x. Okay. That was simple enough, guys. So like I said, y and x, you write this in terms of y and x. 2, for the inverse, we swap. Y becomes x becomes y. Still, the sign is still there, negative. Nothing really changes. We're just swapping the variables, that's all. 2, next step, we then obviously make y the subject. How? Remember I said the 5 goes and kicks the x, becomes 5 to the power x. Negative y is isolated, log falls away. So that's why the equation is negative y is equal to 5 to the power x. Then obviously, we need to always make the subject to become negative. So we divide both sides by a negative 1. This leaves us with y is equal to negative 5 to the power x. Therefore, when we write Kengok in standard, inverse of the function is equal to negative 5 to the power x. You must always take note in what form they ask us to leave the answer. So obviously, I've just gone and written it in the form, the inverse, because I was initially given m of x. So always take note in the question what form they ask you to leave the answer in, okay? And then the very last one that I want to do with us today is when they ask us to convert or determine the equation of the inverse if h of x, let's say h of x is equal to negative log base 7x. So let's look at this one, guys. Once again, step number one, you guys tell me h of x is equal to negative log x base 7. So step number one, what do we do? Okay, I'm sure you guys now should be so well versed. It's not even fun. It's like, you know, you this process, when you repeat it over and over again, should get to a place where like it's so easy now to write the inverse of a function. You know the steps. You can pretty much like, you know, do it in your sleep, for crying out loud. Okay, so h of x, guys, is equal to negative log x base 7. So step number one, y is equal to negative log x base 7. We start there. We write everything in terms of y and x. Step number two, we swap. X is equal to negative log y base 7. Okay, we just swap x and y around. Then very, very important, before we even jump and do anything else, you can see this negative. Before that, anatitafin, wait, before you do the kicking, the thing is there's a negative log. Okay, this coefficient, we need to actually eliminate this coefficient, because the thing is we can't just say the 7 goes and kicks the x just yet. We need to eliminate this negative, right? So what we are going to do is we're actually going to divide both sides by a negative 1, which is very important because this negative, all right, needs to change. Okay, so then we have negative x is equal to log y base 7. Now we are ready to do the kicking. Okay. Now we are ready to do the kicking. So the 7, like I said, now y is equal to, y gets isolated, log falls away, 7 kicks negative x, all right? And we have y is equal to 7 to the power negative x. Now guys, I know for a fact that some people will leave the answer this way, y is equal to 7 to the power negative x. But sometimes, okay, because this is a negative exponent, this is like 7 to the power negative 1x, which you can write as 1 over 7 to the power x. Okay, so you can leave it in this form, but I mean, if we are expressing exponents in as a positive exponent, then remember, this is like saying 7 to the power negative x. It's 7 to the power negative 1 raised to the power x. This can be written as, if you remember in exponents in grade 9, 10, 11, negative exponents can be written as 1 over the 7. What happens is that the 7 moves to the denominator because it's currently a numerator value. It moves to the denominator, and then it's expressed with a positive 1 instead of a negative 1 the minute it moves to the denominator. And then what gets left at the top is 1. So we can actually write it, okay, is as a negative exponential form, but they may insist that we actually write it so that at the end of the day it is expressed as a positive exponent. So if we conclude, we can say the inverse is equal to 1 over 7 to the power x, right? Yeah. Typically, obviously, if we allowed to actually write it as a negative exponent, then it is fine as well to leave it in this state or in this form. Okay, so guys, that's basically it. All right, I just wanted today to go through with you how to actually write or express an equation in as its inverse. All right, so just to recap, we looked at how to convert a linear function to its inverse. All right, how to convert a quadratic function to become its inverse, and then last but not least, how to then convert a exponential function to become its inverse. The exponential function first, and then we also looked at how to convert a log function so that it is its inverse. So I will be uploading this video onto my YouTube channel. You can find my YouTube link in the bio, and those who want to rewatch the session, it's just an hour and 3 minutes, guys. You can rewatch it at your own time so that you can recap on the things that we have done. Tomorrow morning I'll have a live session again at 5:30. Okay, so I've decided for the grade 12s to have the sessions in the morning at 5:30 every day. Okay, it's peaceful and quiet. My kids are sleeping, no one is here, no noise. So it gives me an opportunity to really go through the concept. And I don't want to sabotage the grade 12s because it's a critical and crucial year for you guys. All right. So I'm going to have these sessions every morning at 5:30. So you can join in, you can share the information with others that may need it at this crucial and pivotal time. We'll use these very effectively so that we can cover the syllabus at depth. Thank you so much, Cheikh. I really appreciate it. So that we do not get left behind and we can stay on top of the game. Those who are in the group, I will continue to send what I refer to as rotational tests so that you guys can also have an opportunity to write exam type questions. All right, and we'll be sending the memo at specified times so that we can keep the momentum going. Hey, I know someone sent me a message yesterday and said, sir, it's been such a long time. I feel like I'm losing my maths. The maths is not mathsing. The maths is not gaming. And I was like, oh man, I need to do something. So hence I've sacrificed or decided to sacrifice my mornings. Just before I head off to work, I'll be with you guys so that I can afford you the opportunity and the privilege of getting these sessions and the simplicity of the maths. So that, yeah, guys, we can get phenomenal marks and we can be proud of our maths performance. And I hope, guys, you will take what you've learned. Do not just simply be content with just having learned it and think that you've got it. You need to expose yourself to a variety of exercises. So I don't know if you want a screenshot here. There's a few questions here that basically are requiring us to determine the equation of each of the following functions. So this is from a textbook called Mind Action. So that's that. You can shoot your shot, screenshot it and shoot your shot and check if you are good and you can flow nicely there. These exercises, go and attempt them and see if you can actually convert a function to its inverse. We need to become good at these things, guys. Here's others: logs, converting log function into its inverse as well. You can do these for yourself so that you can check if you are actually if you actually understood what we did. Then tomorrow, guys, I'll definitely have another session. We'll look at how to sketch inverse functions, and we'll take it one step at a time. Okay, and we'll finish inverse functions in no time so that we can go to trig and go to all the other topics that need to be covered. Okay, this is me, guys. I honestly wish you would know. Like I said, this is really it's taking a bit of a sacrifice because it means I need to wake up a bit earlier than usual, and all because of welfare of those that obviously have been with me on this journey. But please, guys, like I said, YouTube channel, the link is on my bio. All the other sessions that I've done for sequence and series are all uploaded on there. You can check those out at your own time. We are now on inverse functions, starting them today, and then we'll take it one step at a time. Every morning, 5:30, be there or be gamed. Cheers, guys. See you. You're welcome, listener. Very welcome. Very, very welcome. So, guys, in my bio, like I said, the link is there. It's Maths is a Game as well. Maths is a Game 5 to 7. You can just check it out. The link is on my bio, the YouTube channel. There are two links there. There's the WhatsApp channel, but the WhatsApp channel is not active. I'm not using it a lot lately. I was using it during the holiday. But the YouTube channel, I'm uploading all the sessions that I do here on the YouTube channel. So please check that out.
Okay, and please subscribe. Really appreciate your subscriptions. Thank you so much. Have a good one.